Chapter 3, being a larger chapter, it's going to be split into two. First part of it will be database systems, and the other one will be big data. You probably heard that term thrown about, at least on the media and stuff. So just thought I'd get you the first part of it. So we'll look at just database systems. Now, a database is basically just a collection of data. Now, a database management system is a group of programs that just help you manipulate the database, and then provide interaction between the database and its users and application programs. If you stay in one of our IT programs long enough, you'll probably take a database class, but this one is not it. So if you look at data itself, pretty much without data, most businesses couldn't run. Data is basically just the raw facts, and it doesn't, as we talked about, I think in chapter 1, it is not knowledge. It doesn't do anything. It's just information, just raw facts that just need to be organized, transformed, acted upon to turn it into useful information. Now, you're going to hear something called a hierarchy of data. And like I said, database is just a collection of integrated and related data files. And this hierarchy can be just about anything and everything. Bits, characters, fields, records, files, databases themselves. You can point to them. And basically all they are is a little different of ranging from, I've got information pretty much down to bit format, put them into fields. If you just think about like your address, you've got name, street number, street, city, zip, and you could just put all that in one big record, where all the things together. But if somebody says, I want to know who lives in your city, you would have to manually look at each of the records and pick out which ones are in your city. But if you organize your data, where if you're thinking about a spreadsheet, there's a column for name, column for street, column for address, column for city. You could then say, oh, now let me just look at that column and identify all the records in that city. If you've taken the CTS115, you can kind of filter that column and just say, okay, give me the cities for Hudson. Boom. And you list all the records in that spreadsheet that related to the city of Hudson. But that's really all the hierarchy data. It's the way I organize it in such a way that you can make use of the raw data. Now, you're going to hear some key terms like entity. And an entity is just a collection of data. It's the thing, a person. In this case, I said your personal information, your personal street address. That would be an entity. It's your address. Now, an attribute of that entity is just one characteristic. So Hudson would be an attribute of your entity, of your address. Of course, the data item could be a specific value in there. So if it was multiple cities, you can say, okay, one data item is Hudson, one data item is Lenore. And then some databases, most databases, have what they call a primary key. What are we going to use as when I first search this database? Am I looking for a person? Am I looking for a town? What's the purpose of this data so that I can get access to what I think is more important quicker? So just to give you a rough example here, you've got social security number, last name, first name, hire date, and what department it belonged to. So you got a key field, all these attributes, so you got an entity for, John Francine Johns. But what they've done is they've chosen the key field to be the social security number. So just give you a rough idea. So that'll help. Now, that's a spreadsheet approach, so to speak. But now, a traditional approach to data management is to for each operating system uses data files. I mean, think about your program, your computer. You've got it organized, hopefully, in folders and files, and so you organize it so you can find it. You organize things so you can find things easier. Well, database management approach is the same thing to data. I'm going to put my information in such a way that allows me to control it, manage it, and to share it with others. And they create systems to do this. So if you've got a database of payroll data, that payroll data would then say, okay, there's probably a program that's running. There's probably, so I've got the raw data of all the payroll information. I got a program that will access that data and generate the reports that I need. So it's storing the data in the database and then having a database management system that interfaces with that data to generate the types of, and then runs specific programs to get what you're looking for. So if I'm thinking about building a database, what do I have to think about? Well, you think about, okay, the content. What data am I collecting? At what cost am I collecting it? So sometimes you may think something's really interesting to collect, but how much time and energy it takes to collect it, it's painful, and it just makes it hard to do. Access. It's like, okay, what data should be provided to who and when? Just because you have the data doesn't mean everybody's going to have access to it, and maybe they don't need access to it, or maybe there's just certain times of the day or week or month or quarter they need access to it. How are you going to arrange the data so that it makes sense? How are you going to physically locate the data? How are you going to store it? How long are you going to store it? What data? Do I have to protect the data? I mean, do I want every student to go in and be able to change their grades on their student records? You think so. I don't. So those are considerations when you're building a database that you need to think about. Now, in designing that kind of database, there's something called data modeling. And it's just a way of diagramming data entities and their relationships so you can figure out what's your best avenue to do this. Now, there's business data, enterprise data modeling, which is like we did with software. There's personal software, there's enterprise software. Same thing with data. You got data that maybe you kind of manipulate and keep track of your own stuff for your own record collection or music collection you want to keep track of, and who's own, But in enterprise, they keep more information, longer distances, and things of that nature. Now, there's also, you got this database and you want to make sure, I want to see how does the data relate to each other. So they create a relational model. It's basically just a useful way to, how do I get to organize data into collection? And it's kind of like, how am I going to relate spreadsheets? So I got two-dimensional tables. And how do I, if there's a relationship between the two tables, how do I do that? Whether on, in this case, project departments and a manager. So each row is an entity, each column represents an attribute. And then it's like, how do these relate to each other? What key terms do I want to link these tables together if I needed to? So if I wanted to generate a report at a manager level saying, what are all the projects that Francine John is on? I should be able to do what they call a query to the database, and it would come back with a list of all the projects. Now, manipulating data, once you got data and you've collected it, more than likely you'd want to change it, modify it, do something with it. And there's a couple terms here. You got to select information. Basically, you're just eliminating rows, or basically collecting rows on ones that So sure, you're selecting data, you're just selecting what information you're trying to look at. Projecting means I'm selecting, I'm taking rows, projecting, I'm looking at columns. Joining is if I'm putting two or more tables together, and linking is if I'm combining two or more tables through a common attribute. Luckily, you're not going to build any databases, but these are just some basic terms that you're going to see. On the other hand, there's also say, once you've got data, sometimes you've got to clean this stuff up. You've got to cleanse it. Data cleansing is basically called data cleaning, data scrubbing, and it's a process of detecting and correcting if there's any errors, duplicates, incorrect, inaccurate information to make sure that your data is the best. Because you've heard the old story, garbage in, garbage out. Well, guess what? If you've got a database with bad data, it won't help your knowledge once you start trying to assess this information and try to pull it all together. And sometimes cleaning this data can be pretty intense, pretty quite costly. But now, data cleansing is definitely different than data validation. Data validation is identifying good data from bad data. You want to make sure the data is correct. But just keep those in mind. Now, we've looked at a spreadsheet, we looked at a small database. Now there are relational database management systems. Of course, those are a little bit bigger, a little more complicated, but they're basically, it's creating and implementing a database system that ensures that data will support business activities and goals. So you got to look and say, okay, which system am I going to use based on what the company is trying to do? And of course, capabilities, types, costs, all that vary in it. Now, one of the systems you get is an SQL database. SQL is just a special purpose programming language just to manipulate data in a relational database. Now, basically, there is when you're thinking about data and databases, there's an acronym ACID, and you see the breakdown of what it stands for. But it basically says, hey, I want to make sure that my data is consistent, it's isolated, nobody's going to corrupt it. So SQL has been around a long time as a standard for accessing databases, and here's using Microsoft Access. If you had your CTS115 class, you had a week or two of exposure to Access, and you probably loved it. Types of activities you can do with this: you can provide a user view of it, you can create and modify the database, you can store, retrieve, you can manipulate, generate reports. Now, if I'm providing a user view, what I want to do is I'm going to define what they call a schema. A schema is basically just a description of the entire database. It's just a layout of how does this database look? How is it? Now, the schema could be part of the database, or it could be in a separate file. But a database management system can reference that schema to find out other information that it needs. Now, if I'm going to create and modify the database, I need to have some kind of data definition language. And basically, that's just a set of instructions and commands to allow us to define, describe the data, the relationship between other pieces of data in the database. Allows the database administrator or creator to describe the database and the relationship. Now, a data dictionary is basically a detailed description of all the data in the database. Now, storing and retrieving data, applications, if you're going to use it, you store it, you want to use it. And mostly you need to get access to it. It's stored through, on a storage device. The database management system tries to control which applications, which people can query the database, or what fields in the database. So you've got some pieces that kind of manage it to make sure that no two people can access the data at the same time. Now, manipulating, generating reports, you're going to do that with a query. I'm going to ask a question of the database. I'm going to query the database, and it basically is just a visual approach to developing database records and requests. Sometimes you get a data manipulation language, which is a specific language that allows people to access and generate their own reports and records. And then a database management system gives you a wide variety of documents and reports and other output to help you understand this. Now, who does this job? Well, the people that do this are called database administrators. They're skilled, trained information systems professionals that help people work with their data to best use that data. Whether it's creating databases, whether it's extracting information out, generating reports, making sure security is done, making sure that the data is still valid and it's keeping its integrity, it's secure. So the database administrator makes sure that database management system is up to date. Now, in a lot of cases, it can be a database administrator. A data administrator is usually a non-technical person. All it is, that person is defining and implementing consistent principles across the data issues. So it's basically, I'm setting up standards of data and definitions that apply across the organization. And data management can be anything from a high-level position, reporting to top-level managers. So here are some popular database management systems, MySQL, some of this stuff. Based on which classes you're taking, you'll be exposed to at least Microsoft Access. You may get some MySQL here. Those are probably the two you'll probably see while you're here on campus. Of course, we heard as software as a system, guess what? Database as a service also. So you can purchase someone else to do most of your database activities. Amazon's got an interesting system. Never used it, but using database management, usually they can be either front-end or back-end other applications. Front-end applications interact directly with the people. And then back-end applications just interact with other programs and applications. So it just depends on who is the database management system working with. Library of Congress has a back end which allows web access to all of its databases, which includes references and books and stuff. So hopefully that gives you a bright, or at least a high-level view of databases and database management systems, not to make you an expert, but just to have an appreciation of it. Thanks.